こんばんは皆さん。もともと日本語でやりたいですけど、今朝7時で到着しました。つまり英語で、今日は英語で。So my name is Tim. So I'm currently a blog contributor. So I used to work for blog like 2 weeks ago. I'm the head of ex-head of that for blog. So I'll be taking on this today's transition to teach you what we do and also our new platform, the AI Arena. So first of all, Blog is a very academic background company where we first released the paper, Blog Defending Against Poisoning Attacks in Federated Learning with Blockchain. So this is our first paper currently on Euros. So supported by Oxford, Imperial, and then the CMU. Yeah. So first of all, just wonder, anyone know what is federated learning? So federated learning is a traditional machine learning method, which is a very niche topic on distributed machine learning, as you can see on this diagram. So you have, normally when we talk about machine learning, everything is centralized. So you want to put your data in a centralized server, and then run the algorithm in a centralized server, and then everything is very centralized. But in order to achieve in a very privacy-preserved manner, you need to use distributed machine learning. So which means you do, first of all, you do local model training. As you see here, each client will train their model locally. So you use all the same model. You can use different data set, which is also known as horizontal federated learning, where we in this circumstances. So everyone train their model, and then what? And then submit the model weights to a server, which acts as an aggregator here. So we train, and then we submit the model weights, and then we aggregate. In the end, we will form this global model is trained by everyone. However, in a traditional federated learning or distributed machine learning method, we have this poisoning issue, which means we cannot validate whether the client is submitting the right data for the model or not. So because once you got into this whole process, you can't validate. So everything runs automatically. You can only check what in the end of the process instead of in between the process. So if one of the client acts maliciously, it will impact the whole model performance. So what we found out is that are we able to find a good solution to actually use some kind of cryptography or blockchain, the decentralization approach to fix this issue? So as you see here, advanced crypto technology such as zero-knowledge proof, where it can be used in between aggregation proof, or use the blockchain to act as a validation layer on top of it. So where we come out as a solution, the incentive mechanism. So this incentive mechanism actually inherits the mechanism of proof of stake, where each client will need to stake first in order to participate in the training round. And then we evaluate in a peer-to-peer voting mechanism, which I will talk later. After that, we reward user on top of their action. So why? Because once clients start to unbound with economic purpose, they will act on this because you want to get reward. If you act maliciously, you will be slashed, where it's also known as a penalty to your token. So as I just mentioned here, our inspiration came out from the traditional proof of stake, which is also happening on Ethereum at the moment. So the transition from power of work to proof of work to proof of stake. So here is a more detailed diagram to describe how we interact between blockchain and the machine learning process. So the first block generated by our protocol is the local model update. So where you can see first the proposer and the voter are both trainer, where they first need to stake into this stake pool of the mission, and then they will the proposer will upload the local model, upload the local model weight, and then we have this global model aggregator running in a smart contract. So this is decentralized and then trustless. And then in the third block, the voter will download the result from the previous two blocks previous log in this local model update and start doing the peer-to-peer voting mechanism to evaluate whether each trainer is acting honest or not. If everything goes through fine, we will finalize the results and then start to see whether we reward or slash the participants. So here is the multi-round reward slash kind of a process where this is happening in each round. So the top row is the ones where we assume everyone is acting honest. So we will see that, okay, here everyone's acting honest, we'll just pass through and then everyone will just get rewarded in the end. So for example, if someone acting dishonest or acting malicious, it will also go through, but in the end of the last block, we will slash out the malicious actor, and then we will revert the whole round, and then carries on the next round. So in the end, we can actually figure out how much percentage we will reward to the rest of the participants. So here is a pseudo code. If you're interested, you can take a photo, or I don't need to. I will not go too deep into this, and then I'm just explaining it. So how we set up our experiments doing the thesis. So we actually have this 50 clients within the system, and then ran on top of PyTorch and with one NVIDIA Tesla T4 GPU. So I'm not the one who conducted the test. So it was done by the team. So, and then we have 10% of clients, 10% to 40% of the clients selected as a malicious client, and then we run a fat average on blockchain. So as you can see, here is the malicious voter. So assuming from here is the 10%, and then the end is the 40%, we can see that with 10%, only when we reach like, so when we have two clients, it's actually quite deep. So it's quite narrow, and then only after 30 apples, we can figure out the malicious. We will assume that once it reaches to 40%, it's actually going to be very hard for us to have a very positive result because it is approaching 50%. So if you have like around 50% malicious act, it's basically it's not going to work as a good model because the result will lean into a two-side average. So and then here is the analysis of token distribution. It also shows that I'm not technical on this, so I do want to apologize. So this is the presentation by our CEO, who's conduct really academical analysis. My background isn't very technical on the side of analysis, so I will just quickly go through the graphs. So after explaining the base mechanism. So we have the analysis of token distribution. So the expected average token of malicious proposer is down during the training process. And then also the token distribution for malicious proposer. Similarly, we expect the average token of malicious proposer exhibit a higher rate of decrease when a large volume of participants is selected. And then here's the survival time of the malicious proposer. If we have more percentage of malicious proposer, the survival time is longer, but yeah. And then lastly, I think this one is more important to understand that how, in the end, how we evaluate our results of performance. As we can see, we did 3 different benchmarks. The first one is fat average with malicious attack, and then fat average with blockchain, and then fat average without malicious attack. So we can see that at 10% of malicious user, we are achieving similarly with all 3 of the benchmark. And then, but if we check on the 40%, we can see the first one with malicious attack went down to 70% accuracy or 70% performance. But however, with our method with blockchain involved in, so we can actually still sustain on top of 95% of performance, would compare with that average result malicious attack is the 97.5% accuracy. So in conclusion, what we found out is that using a proof of stake mechanism on top of traditional federated learning can actually help to prevent model poisoning, because you have an economic embed into the whole process, where by using the slash and reward mechanism, the client will react more honestly because of the reward. So here is a future work we just released our paper on. It's called Zero Knowledge Federated Learning. So the whole thesis of this research is to prove that when we try to aggregate into the aggregator, is that actually real or not? So you want to make sure that all the client's result is correctly aggregated into the aggregator. So if you are interested in this research, you can find me and or directly visit this link down here to read our paper for more detail. So for this talk, we will more focus on the base technology of Flock and our AI Arena product. Yeah, so these are the 3 papers currently out on IEEE and Europe for the time being. So next week, I will do a short introduction on our current product, which is called the Decentralized AI in Practice, the AI Arena. So what we want to do is, so I described what happened in our paper, the block, with federated learning and blockchain, but in general, the research, it's very hard for research to become a real product. So it took us a long time to go through pit holes and understand how we want to do it. So now we come up with a solution to split into three processes. So currently we're on the stage of AI Arena, which is a cargo-like platform allowing users to compete through different tasks and build models. So currently the data can be private data or open data. It's not really used on top of federated learning. But however, the second stage, where on the FL, Federated Learning Alliance part, will involve our whole structure of federated learning, where we want to use the foundation model created by AI Arena to train on privacy data. So before we started working on the AI Arena, we actually have worked on making the product out of the academic paper, but the result of that was it's very hard to push to the market, because users need to understand why they want to train on top of private data, and then they need to understand what is federated learning. So we took a step back, and then we went on working on the AI Arena. So we want to say that, so first we want to have this foundation model where we train users to train the foundation model first, and then we can transition them into the FL phase, where they can start running nodes on top of their machine and train local data and privacy data. So here is, and then the model generated by AI Arena or FL Alliance can also be used in different applications, whether it's blockchain related applications or general public, the Web2 application, it will all work. So as you see, so the 3 target we focus is, one, incentivizing the algorithm innovation, and then augmented with preparatory data, and then fine-tuning alignment with user feedback. So here is how exactly it works on the blockchain AI layer and data layer. So we have blockchain acting as a staking consensus and also incentivization layer. As I talked before, we are performing a stake reward system using the blockchain. And then the AI layer will be mainly serving as a task creation, model training and validation, and then serving the hosting the model. So currently we have this single node training process where user just need to run a simple script on top of their computer, and then we will be running, participating the training task or validating the task. So you can see we have 4 different types of user segmentations: the task creator, who create the task. Maybe, so for example, this is some companies we currently working with, like Character X, they want to train on top of a specific character, like and from animation, from TV theories, but they don't have they don't have enough data or they don't have enough computation to train. So they come to our platform and release a task. Or we work with some on-chain data company. So one of the data company we work with is called 0x Scope. So they have a lot of data, but they don't have the computation power or domain experience to transition their data into a model or transition their data through model into a product. So they also come to us saying like, okay, so they provide us the data, and then we have the community to support, and each community member can use the data to train the model and earn reward. So, and then we have the training node who train the model and submit the model result to blockchain. And validator is also coming from the community where they validate the training result. So, so in my opinion, so what I would call this is more like a community-driven machine learning process, where we break down the traditional centralized machine learning process into community, where a community member will manage the model training. They will manage the model training result validation. So everything is transparent and traceable on top of blockchain. Yeah, I will invite Jo to come up to share his experience with us after I complete the talk. Jo, take your time. Yeah, so Jo is one of our early participants in our training network. That's also why I'm here today. So he invited me to come in and deliver a talk. So I'm based in UK. So took a long way flying from UK to here. Jo, do you want to try and give some words on your experience?
So first of all, thank you, team, for coming over from Shanghai. So we all know that we have a problem with Microsoft or CrowdStrike yesterday, so we got really big delays on the flight. So thank you for your effort there. But I didn't expect you to put me on the spot for that. But anyway, okay, let's do it.
But you know, it's all about freestyle.
Yeah. So I heard about Frog about 2 months ago from a mutual friend, Ivan. So I started participating with a simple validation task. So all I need to do is to install a few libraries using context, quite straightforward. So my job as a validator is to validate different submissions from the trainers. So that was really easy. So we can stick token, so FML, token on it, and then you can earn the reward by using your resource, by your computation time. So after two or three tasks as a validator, so I feel this is like interesting project. So I decided to get a new GPU, or get a new NVIDIA 4090, and became a trainer for one of the task 5 for FastPaster. So it was also my first time doing fine-tuning of a model, so just start from scratch. I was thinking about writing a blog post about it, but because I have to handle this token up first, so but I probably will do a blog post later on about the process. So basically what you need to do is to come up with some training data, some information from the internet, so you structure them into a questions and answer pair, and then use it to fine-tune one of the foundation models. So I use one of the big one, the typical one, I forgot the name of it now, and then I end up with a model just good enough, just not overfit seriously to the problem, and I came third for that task, and I got some, I think I got 1,500 USDC for that. So yes, so almost pay off my GPU, but it was really nice. So I'm not sure if many people heard about the other project called BitTensor.
Yeah, BitTensor.
BitTensor. I know Alex know about BitTensor. So it's kind of similar concept. So
I think I can explain a bit more on that. So BitTensor is a competition network. So where they initially started off, so where you have those subnet as a training task, where you can act as a training node or a validation node. So normally speaking, people will compare us with BitTensor. But what I tell all those people who ask that this question is that Bitensor subnet is less sustainable because once you run out reward, you will kind of like, you will get slashed or you need to carry on. It's a lot of effort, maintenance the subnet, because there's only that many data you can use to train, and then it's only that many trainers will willing to train. It's also a lot of economic impact within the calculation, how much reward I can earn from this subnet. So you are competing with the trainer, and then you are also competing with other subnet. But for us, we are more sustainable because we are task-based. So each task is currently around 30 days, 21 days to 30 days. So within that 21 days to 30 days, you want to train on a specific assignment. For example, the task 5 is all about Farcaster. So during that 21 days, you only need to train that data for Farcaster. Farcaster is a decentralized social layer where they have a lot of it's very open and flexible framework, allows you to develop a lot of stuff. So we want to train a GPT, it specifically answer your question about Farcaster documentation. And then also similarly to the example I raised earlier, where we train model for character X on top of animation character on their character, you don't need a long sustainable subnet for that. You only need to have that one period of time where you focus on training the model specifically for that piece of data, and then you compete on top of the performance of these models. I will show you a quick showcase on our website in a bit. So that's how I consider our difference between us and Bitensor. So and then this is the older slides, to be very honest. I think we launched the platform around 2-3 months ago. Yeah, where Jo started knowing, I think it's the third week of our release. So currently we are surpassing 50K submissions and validations on top of our platform in a very quick pace. I don't know how many people are from Web3. Do you mind raise a hand or know crypto or yeah, I think that's a known and answer. So we do partnership with top talented people from this web crypto and AI niche. For example, Foundry who holds 80% of Bitcoin computation at the moment. Is one of the top computation provider for Bitcoin mining. And then Akash is a very old decentralized cloud service provider. And then we also have people like from silver medalist from Hugging Face and Jo from Numerai AI. We're looking forward to collaborate with more AI background developers or machine learning engineers to togetherly working on this whole network and understand how we can do the whole training process better. Our machine learning community-driven machine learning. Yeah, so the model has also been used for a lot of other companies in Web3, but we also have very interesting use cases in such as healthcare credit scoring. So in traditional Web2, federated learning is heavily used in privacy-preserved data training and modeling. So one of the largest sector in this privacy data is healthcare. So we have collaborated with multi-country hospitals. For example, OHI's University, and then one hospital from China, and NHS University College London Hospital, one of the largest hospital in UK, and then also a hospital from Korea, St. Mary. So so for these cases, it's very rare in traditional Web2 or traditional world because you have a lot of privacy issues with traditional centralized aggregator, where the aggregator need a strong trust. If the aggregator got hacked, basically your private data is exploited. But however, if we achieve it from the blockchain, because we are only submitting the weights to the blockchain, we don't necessarily is having this trust issue on chain because chain is already trustless. So that's why we are able to achieve multi-country collaborations on healthcare. And then also Request Network is on-chain credit financial application that we work closely with to help them to calculate the credit score privately for a different company. Yeah, so I will do a quick showcase. One is to walk through our platform, and then two is going through our GitHub. just to showcase you what's going on with the validator and trainer. And then thirdly, if you guys are interested on how to run training node on decentralized cloud service, like I'll just raise a hand in the end. So I'll also showcase. So normally speaking, if you have the token, the token part is hard. It might take you like 2 hours, 3 hours just to get a token, but once you have the AKT token, the whole deployment process is very easy. It's gonna be like around less than 5 minutes, basically. So let me just go to our website. So train.flock.io is the website for this whole platform. Of course, because we are a crypto and AI company, so you need to have a wallet to log in. So as you can see, I logged in here. Let's go to the dashboard. So currently we have around 76 active training node, 119 active validator, and then 57 delegator. So you can see the training submission here is we are surpassing. I think today is around 2,618, which is growing quite well. Consider we started off in May, and then so I haven't been going through the website for a long time. So I will just go through the tasks. So currently you can see we have those tasks. So the finalized task means the task has been finished. So then we can see the newest task here is a text to SQL agent model for blockchain. So here you can read all the specific description of what you need to provide for this task, and then you are able to run directly from our Git repository. So this is the testnet training node quick start. So we actually provide, so you can choose 2 ways of running this. One is using our one full script, which is one line. So let's see. So it's this one. So all you need to have is having a task ID, which is 9, and then a Flock API, which you can generate once you log in, and then your Hugging Face token plus your Hugging Face ID. So this full automation script will run 5 different models once you activate that. So the QN 0.8 billion, 1.5 billion, 7 billion, and also Gemma 2 billion and 7 billion. So this is all happens automatically. You need to change the data set. For obviously, you need to change the data set for the training. Otherwise, it will directly run on top of our provided dummy data set. Otherwise, if you know how to build your own kit or your own tool, you will need to you can run the second part where submitting your model directly from the API just to use your own kit. So this is the training part, and then so also if you don't want to train as Joe did in the beginning, so you can also participate as a validator. So here is the validator repository, which is also very simple. So all you need to do is just, I think, it's just running this simple line of script. It will just run automatically in behind. In the background, and then we also did a lot of force and back feedback with all the community members. So now it actually runs in a loop. So it will run until the moment where you reach the maximum daily limit. I think the daily limit for validation is how much?
It's like it's per minute. So you can have 1 request per 3 minutes.
Yeah.
For trainer, you can only submit 6 submissions per day.
Yeah. So for trainers, you can only submit six submissions per day, and then for as we just discussed, for validation data, there's a request limit per 3 minutes. But everything now is very optimized to run in behind, and then for validator. So if you want to start staking on the task, you need to come into this stake page, where you can choose to become either delegator, training node, or validator. So the delegator is actually the easiest one. All you need to do is just delegate, or send. Basically, the easiest solution explanation is send your token to someone you trust, and then they will run the mission for you. You don't need to do anything, and then you get a share of the revenue on top of how much token you send to them. So So I will not just showcase on, and then you can see here, they have this reward ranking. So I don't know, this is the new feature, but I believe it's the ranking to tell you like who has the best hardware or network hardworking index. Or I think the hardworking index is actually means how many tasks they participate and versus their performance on top of the task. So you can just choose one that has the highest score, I believe. And then you can just delegate, you can just send your token to them, and then they will help you run the mission. So for training node and validator, those are very similar. You need to select the task, and then you need to stake the token. So currently we can see that the total stake of this task is already around 6,000, and then the requirement for minimum of the stake is 10, and then you can estimately get around 50 token per day on top of your performance. And then here is the validator. Let's go and check it out. So validator is slightly higher. You need 50 FML in order to participate as a validator. So I will not showcase you on how this works, but once you stake, you will be able to participate into the task. But for each task, you will need to choose whether you want to become a trainer or validator. You can only choose one to work on. So it gives other people better opportunity. So we don't have a very black box syllabus attack issue in the task. Yeah, that's pretty much about how the Block AI Arena platform works out. So just quickly showcase Akash network. So this is the Akash network where they have a lot of GPU on behind where it allows you to select for. So the overall cost of these GPU is quite cheaper than AWS or GCP in general, because you can actually choose about the time and depending on how much AKT token you put in. So once you come into Akash and then you want to deploy now, and then everything becomes very simple once you have the token. So I don't know what is the exchange here in Japan, but for me, I just purchase it on Binance, and then I will transition the token to my wallet. And then you can search FLOCK. So we have a deep collaboration with Akash, where you can directly deploy Flock Validator or Flock Training node. So if I select Flock Training node, I can just deploy it. So similarly, all you need to do is just to replace the variable here, the API key, your Hugging Face username, task ID, and Hugging Face token. After you fill in that, you can choose which type of card you want to use. So from our minimal spec, we suggest running a validator should be around 4070 GTX. For training node, the minimal spec is 16 gig GB of VR virtual RAM, so which is around 4090, I think. Yeah, that's probably the right spec.
So I think I put it on about 24 gigabytes.
Oh, yeah.
Yeah. So that's more than enough for most of the tasks.
Yeah, so you need at least 60 gigabytes of virtual RAM in order to run a training node. Otherwise, you will result sometimes in a virtual memory run out kind of a situation. Yeah. So thanks very much. That's the talk and the demo to our platform. And then if you are interested in running or participate our training platform, you can scan this QR code. We have a form for whitelist. So currently, I think we are on our way to eliminate cancel the whitelist, but probably by the end of the month. So you can always come to me and talk to me. Even though I don't speak that perfect Japanese, but I will try to help you. Thank you very much.
So, any questions? Okay.
You talked about the requirements for the, like, I guess the hardware requirements for like running a trading node. Is it the same requirements to do that as a validator as well?
No. So for validator, you don't run whole training process. You run a portion of simulation. So that part doesn't cost that much. So I can give you my spec currently running on all the training node and validator myself as a part of a testing process. So I have a 4070 that actually runs fine, but you're obviously, if you want to submit more submissions on a daily basis, you want to have a better card to accelerate your training process. But for validation, it doesn't matter. It just runs on the background. So once it pick up the validation task, it will just run it.
Okay, cool. Thank you.
Okay, thank you.